find him.
I mean, it's not.
I know there's somewhere in
This
here.
one has 53 grams. That's a lot. Almost like half a jar. You know, I think it's like 18 grams. 53 grams. I mean, yeah, you get this. This is like a dessert.
Guys, work out.
Like back to the racing food. I'm wondering about like carbonated drinks are better. Like back when we was drinking drink water and ate.
Back in your day, Coke was like.
Do you guys
Like
salt?
Coke
Like
was
for real?
Coke was
Is
like
it
a
really disrupting? And it's
Coke was like a dessert.
Seriously.
Like I don't do Coke. Like I don't.
Hey,
Nobody cares, dude. Shut up.
no, stop. No one needs the last word. I'm having the last word. Stop. Shh. We're going to go. Jaden. Both of you. Both of you. We don't need the last word. I'm having the last word. Alright, so Noah's out. Is anybody else missing? Oh, Denson's out. Has anybody seen Pedro today? Savannah, has anyone seen Spence today? Connors is here, Connors here, Frank is here. Sorry, my shoes are so squeaky. Yeah, they're very new. This is the second time I've worn them. Alright. So, sketch a graph with no solution. So what do they look like? Awesome. Not intersecting, aka parallel. Okay, so write an example of a system of equations where the graph would show two parallel lines. So think about what we did. The slopes are the same. Awesome. So you could have written down anything as long as your slopes were the same. Brendan, are we paying attention? Okay, so as long as your slopes are the same, we're good. All right, does anybody want to share what they wrote there? Two what? Yeah, two equations. Uh-huh. Cool. Anybody else do a different set of lines? All right, so that one was kind of a tricky one. Okay, so can I see yours? All right, Ethan did -1/2 and -1/2. So your slopes have to be the same. All right, thank you. So I want you to write parallel lines have the same slope. And then I know this symbol is from geometry, so a long time ago for you, right? But that little symbol means parallel. Do you remember that symbol? Yes, no? All right. Why would two functions being graphed at the same time help us in any way? So in other words, how do you think this is used in real life? Yeah, you could define a solution, right? But the solution of what, really, right? That's okay. This one's kind of a tough one. So think about if you have, so some of you are in econ, right? So that's kind of a system of equations, right? So you have your supply and demand, right? So your solution will tell you what you should sell it for and how many people are going to buy it, right? That one's normally a like a parabola, and those are more like system of inequalities. All right, so this is done in economics law. Okay, so trying to figure out how much to sell your product for. All right. Think about times we don't want things to intersect. Cars, okay, or airplanes, right? If you're in an airplane, you do not want those to intersect, right? Now, those lines would be technically skew, but still, that's a system of lines, okay, or parabolas in that case. And when they come down and land, we don't want them to land at the same time, right? So they're looking for those lines that don't intersect, all right? So they're useful a lot of ways in that. Also, think about video games, right? So when you're playing something, you have a character or something traveling along like a grid. Okay, you can't see the grid, but they've made it. Okay, and then when you intersect it with a treasure chest or whatever you're supposed to do, or a ghost, okay, or a zombie, okay, then you die. Okay, so they're using systems of equations to code that. Okay. All right, so we can say video games, streets intersect, so we can say traffic, airplanes, supply and demand. Have y'all done econ yet? Okay, so you'll probably talk about supply and demand, right? Okay. All right, so what does substitute mean? Plug in. Or replace. Right, if I have a substitute for a day, I don't stay there, right? I don't have a substitute and then I'm here as well, right? We switch, right? They substitute for me. They replace my spot for the day. All right, and then last one, how's your day going? Are we ready for the weekend already?
It's been a really long week.
It's been an awkward week, for sure. All right, so...
Is it that we're graduating in June and not May? Are you sure?
we just got an email last week about the...
Okay, good. We just get emails. Like, people are posting, like, on Twitter and...
I think there's
like,
two
on-
groups, because I'm
I
gonna
don't
graduate in
know.
June. That's what the
I have no
email
idea,
said.
because it was like a list of schools that were graduating on certain dates, and it said that Central and AE were graduating on the same day, and ours was at 6 o'clock on June 4th.
Oh, well... Oh, okay, but you won't be going to school until June.
Oh, okay.
Yeah.
So, like, we let out of school, like, sometime in
Like,
May, and then
yes.
graduation is in June.
So I guess they're trying to split it up.
I
Yeah.
was like, I'm not about to be in school until June.
No.
I wanna get out
No,
of
no, no.
here.
You will not be in school till
I
June.
was like,
Can they do that?
No.
I think that's what
No, you'll still do your like exams. That's a good question, guys. You will not be in school until June. Okay. Yeah, you'll still take your exams and everything, but so what they normally do is they normally have like 3 or 4 schools on the same night, right? But that's too many people coming in and out, so that's probably why. I have no idea. But so they have to probably do like maybe 2 schools and spread them out further. Yeah. Yeah. All right, so let's look. So we're going to focus on this right now. So what does substitute mean? So today we've already solved by graphing. So today we're going to solve by substitution. Okay? So we talked about how substitute is plug in or replace. Okay? And when we solve, remember your solution is an x and a y. Okay? So we're going to have to solve for both of them. Okay. So, man, I thought I fixed that. All right, well, whatever. It doesn't matter. Okay, so I'm going to look at where it's easy to find, like, where we can get x equals or y equals, right? So if I look, both of these have just 1 in front of them, but this one has a -1. I'm going to solve for x, okay? I just chose that. There's no real reason why. Connor, are you really excited about it? Solving for x? Oh, okay. Well, then, that you should be excited for that. All right. So I'm going to solve for x. I just chose it because there's no number in front of it. There's no negative, so that's why I'm choosing it, okay? So to solve for x, so let's ignore this bottom problem for a second. What would I do to solve for x? I got to get x by itself. What should I do? Awesome. So plus 4y to both sides. Can I combine negative 8 and 4y? No, don't do it. So you have x equals negative 8 plus 4y. Now that we've done that, we can kind of hide it. Don't look at it. All right, so this kind of goes back to the other module that we just did. Okay, so we have 4x, but what is x? What does x equal? We just solved for x, right? So what does x equal? Right. Right? We know what here's an x, and we know what x equals, right? So I'm going to substitute x for negative 8 plus 4y. All right? And then minus y equals 13. Okay, so do we see that all I've done to change this was replace x with what it equals? Okay, are we good? All right, so now I can, so the goal is to just get one variable so you can solve. Okay, so now that I've plugged in this for x, now I've got one variable and I can solve for it. Okay, so let's go ahead and distribute that 4. So I have negative 32 plus 16y minus y equals 13. Now, these both have a y, so I can combine them. So negative 32 plus 15y equals 13. Perfect. Is that 45? Yeah. Then divide by 15. Y equals 3. All right. Are we finished? So remember, our solution crosses as an x, y coordinate. All I know is y, right? So what do I need right now? Yeah, so we got to plug in y so I can find my x. All right? So you can plug it into this one or this one or this one, okay? Because this x equals negative 8 plus 4y is the same as this. I'm going to go ahead and plug it in to this one because it'll be less solving. So I've got x equals negative 8 plus 4y. But what did we find out was y? Y is 3. Okay, so x equals negative 8 plus 12. So x equals 4. So now these two lines cross at 4, 3. So if I write down a coordinate, that means they have how many solutions? One solution. Okay, so if you actually write down x equals or y equals, then you need to be writing down one solution. Okay? All right, so this is solving by substitution. All right, let's try the other one. All right, so I'm going to choose to solve for y on this one. Okay, there's no negative on it. And I just chose it. No particular reason. All right, so to solve for y, what do I need to do? Perfect. I'm going to add x to both sides. So from that, I get y equals 2 plus x. All right, so now, if I'm looking at my other equation, I have x minus y. But what is y? Y is 2 plus x. Now be careful, that negative needs to go to both numbers. So I have x minus 2, and then, so that's a negative 2 and a negative x, and I get negative 2. Now what happens when I combine these? It cancels out, right? So then I'm left with negative 2 on that side and a negative 2 on this side. Well, wait a second. What happened to my x's and my y's? Okay, so we've got one solution. What are our other options for our lines? We wrote them at the top. We have infinite and we have no solution. If we get a true statement, do you think it's going to be infinite or no solution? Well, does negative 2 equal negative 2? Yeah. So it's going to be infinite, right? So that means no matter what we plug in for x and y, it will be a true statement for both of them. It'll satisfy the top equation and the bottom equation. Okay, so I can plug in negative 1 million and the square root of 3. And that will work for both equations, okay? Because it's basically the same line. So if you get a true statement like negative 2 equals negative 2, that is infinite solutions. Okay, so that just means that those lines are the exact same. Okay, let's try to draw like a little example of each one. So how to spot those? If you look, these are multiples of each other, right? If I took this first equation and then multiplied the whole thing by negative 1, I would get that second equation, right? So it's a multiple. So that would mean like if I had like 2x plus 2y equals 7, all right, and then I had 6x plus 6y equals 21. Okay? Just looking at that, these are multiples of each other. So what is multiplied to get that second equation? By 3, right? So if you look and you see that these two equations are the exact same, just one's a multiple, then you know you have infinite solutions. Okay? So that's an easy way to spot it. All right, let's look at the next one. So, which variable is going to be easy to solve for number 9? Why? Because it's by itself. So I'm going to add 4x to both sides. So I'm going to have y equals negative 5 plus 4x. I didn't have enough room to like write the plus 4x. Oh, I guess I do. So I'm going to hide all that. So I have negative 12x plus 3y equals 7. But what is y? What is y? Yeah, you're fine. Negative 5 plus 4x. People that have their Chromebooks open, are we paying attention? Okay. All right. So distribute that 3. Okay, what happens to our x's? They cancel. So now I have negative 15 equals 7. Is that true? No. Okay, so then do you think we have one solution, infinite, or no solution? No solution, right? If we get a false statement, that means no matter what we plug in for x and y, it will not work for both equations. Okay? So, negative 15 does not equal 7. So that is no solution. So that means that the lines are what? What would that look like on the graph? Parallel. Awesome. So the quick way to tell about these, the shortcut, is that you see that the x and the y's are multiples of each other, but the constant is not. So you'll see, like, so let's do the same one. If I had 2x plus 2y equals 7, then 6x plus 6y equals 8. Okay? Both of these are multiplied by 3, but once I get to the constant, it's not multiplied by 3, right? So then you'll get no solution. Okay? All right, I want you to try number 10 on your own. So I want you to try number 10 on your own. Yeah. If you need help, raise your hand. Ask the partner. That's okay. That's okay. Because you can have x equals 0, right? You can have y equals 0. It's weird, I know, because we don't do a lot of that. But you can get 0. Yeah. So if you're getting 0, that is okay. So which variable would be easy to solve for? The x, right? So now to solve for x, I'm going to add 6 y.
I'm guessing if you divide the
So you're not
zero,
x
it's still going to be 0. So what's 2y equals 0? Yeah.
Oh, negative. Uh-huh. So 7 times. Yep. Okay. David, you doing okay?
Yep.
So,
Okay. Uh-huh. Yeah. You need help?
No.
Okay. You doing okay?
wait, I need to help one more time.
Okay.
So, how would I solve that?
So now you're going to plug y into either one of these. I would plug it into this one, because then if you plug it into here, you're going to have to, like, nah, you won't have to solve because y is 0, but normally it would be easier solving this one because you don't have to, like, divide. Oh, sorry. Do you need help?
No.
Sticky today?
Well, I'm so confused.
Big stretch. Elena, you okay? Yeah? Well, so equals 0, right? So what would you normally do with that 42? And then 0 divided by anything is, yeah, so y would. So then you would plug in 0 here to get the x. Yeah, perfect. Okay. So that'll be, let's see. So that's going to be 6. Okay, hold on. I can't hold it. Okay. Is this? So let's look at. This should be your x. Alright, we're looking at this one. Add 6y to both sides, and that should be y. Okay. Yeah, if you're finished,
Is that what you've got?
check your answer with your friend and then go on a math break. It's 10:40, be back by 10:50. Okay. You're doing good. Oh yeah, that's fine. So, that's gonna, that's
I didn't-
negative
I went
7,
wrong.
right?
Did you get,
So 7, when we add 7 to negative 7, we get 0, right? Now what would you do to solve for y?
I'm such a genius. It's so hard. Carrying around this big brain.
Oh, why don't we play? This is what would you do? So this is 42 times y, right? So how would we get rid of 42?
An egg, a flag, an egg on fire. Yeah, or an egg on fire. Like a
You
golf
need to
flag.
divide, right?
And then like draw an egg on fire, you don't need to draw.
So 0 divided by 42. 0. So now, plug this y into this.
Have it like sizzling, like you did. Yes.
He already knows what would happen. He doesn't want to use enough pain. I think he needs to be destroyed. Like he's yes. He did it. Oh my goodness.
It's like a golf or like a flag, so like a flag, and then a flaming egg going into the wall.
Are you okay though? Don't. What'd you? If we plug in 6 times 0 is 0. So I need that needs to be 0. No, negative 1 plus 0. So then it needs, so your y is this. This 6 is 0, this is negative 1. Alright, I'm going to take this and let's call it
just get plastic. Oh my god.
Hey.
That's what's happening. You're saying that. I was like, what? I just said, oh my god.
Hey, I'm gonna post a video, today.
I'm not sleeping in 3 o'clock, honestly.
Okay.
Maybe depends on what we're doing.
If we're just doing recording,
the notes
presentation.
Yeah,
and
we're just doing presentations or if it's like
okay?
an essay or something. I did that process essay.
be
did?
Yeah, I did it on how to make that feta cheese and
Oh,
tomato
pasta.
pasta.
Good idea.
What's it now? I don't know. I don't know how to make anything. I know how to roll black.
Yeah, now you roll up one step by step. First,
Dude, I really thought about it. I really thought about it. I was probably in trouble.
Yes.
How
If
would
you're
you eat that
starving,
healthy?
you need actual food.
Are we doing this entire packet?
I don't know. I don't think so.
Is it fresh?
can we keep doing what we're doing, or are you gonna make it harder? That's what I've noticed.
That's
Yeah, you
Normally
do-
when I
you
get
give us
something, I just get it for the
easy
first
and
time.
then you like the first half, and then you let us do it by ourselves, or like, you probably just increase it.
I don't think they're that much harder.
We've also been doing this for like 50 years.
Yeah.
50 years. 50 years.
Because if we're just
Wait, y'all have 1 minute.
I'm about to wash it off.
Oh, okay. Guys in the hallway. It's 10:50.
Have y'all watched that disappearance at the Cecil Hotel on Netflix?
Mm-mm.
It's good. I don't remember what part name I put to talk about.
Thank you all for sanitizing your hands.
You think we could get something for it?
Chick-fil-A.
You think you'll ever?
Yeah.
I go to Chick-fil-A if I bring it back.
No, because I don't eat meat.
What?
Oh, I forgot.
I don't either. Are you vegetarian or pescatarian? That's what I am too. That's so
I've been pescatarian for 9 years.
They have.
Wait, where is it? Pescatarian.
What?
Really? Yeah, I love that. I was a pescatarian for almost 10
If
years.
y'all ever go
I
to
was on it 'cause I was like Chick-fil-A.
Chick-fil-A, I would just be happy with the unsweet tea.
What's an unsweet?
I could go back to being pescatarian, but I think
I love everything.
honestly, if I
Ethan!
was back pescatarian, I
Don't
would
laugh at
eat
that.
all meat except like chicken.
Okay.
Because I don't like red meat. I don't.
Did she not tell you the story when she started being a vegetarian? Wasn't like in college or
You said
something?
9 years?
It was
Oh.
in college, wasn't it?
Mhm.
And you couldn't like afford like food, so you like started eating just veggies and stuff.
No. No, it was, so you had to have a meal plan at UT
Why?
if you were a freshman.
Why? What?
You have to have a meal plan if you're a freshman.
That doesn't make any
Why?
sense.
Because they just want you to spend more money.
That's stupid.
So, so you have like, I went to the cafeteria every day in like where my dorm was, and they had the meat there. It was like, the turkey was like all slimy looking.
Ew, boy.
And then the burgers just looked like hockey pucks. Huh?
Could you not bring your own food?
Yeah, but I was in a dorm, so you didn't really have like a lot of room to make it. You had a
There's
microwave.
There's a lot of food stores that have them.
Yeah, but the thing is, then you can't like make it.
What do you mean?
Like I would only be eating like mac and cheese if I went to the store because I only had a microwave in my dorm. You don't have like a place to make
I'm
food.
talking about getting fast food. You can go get some.
Well, that would be really expensive. You can't just like eat fast food all the
Buy like
time.
one of those stovetops, they're like portable.
Yeah.
Yeah, but those can cause. Oh, like a griddle.
Yeah,
Yeah, probably. But so like the burgers always look like hockey pucks and like it just all looked just gross. So then I just never ate meat, and then when I went home and ate meat, and I felt really sick. So then I was like, whatever, I just won't eat it. That's kind of what happened. And that was 9 years ago. I'm getting old.
You think we'll try
Oh,
to
sure
eat
got
your
gang. Oh, clean. You hit that 3-0.
I know it's gonna hit.
Do you think that you'll try meat again?
Yeah. I will. There was one day I accidentally ate a pork rind. Because I didn't think about it, and I hadn't had one since I was like 8. And I was like, oh, pork rind, and I ate it, and I was like, oh, I'm an idiot. But that was one time in 9 years, so. No, it does count. Oh my gosh. Okay. All right, so let's look at this one. All right, so y'all should have added 6y to both sides. So you get x equals -1 plus 6y. Plug that in for x. Pedro and what's his face are going to hear this at home, and they're going to be like, what are y'all talking about? Okay, so we get -7 plus 42y plus 6y. Then you should have added 7 to both sides. What? Oh, he said he was hungry, so I gave him an apple. Alright, so you should have gone here. Now divide both sides by 48. And I get y equals 0. I noticed a lot of you did not add this 6y to the end, but you ended up getting the same answer because y was 0. Alright, once you've done that, you plug in 0 for y. And x equals -1. So then you should have -1, 0. All right, so remember I told you if you get a y equals and an x equals, that means you have one solution. What?
Well, I was like, he was just I was just wondering, like, just like imagine you like being hungry about me, like, I was like, you get the basic,
I'm a pescatarian, so I eat fish still, but probably only like once a week.
So basically, like,
My main day is vegetarian, yeah.
I don't think I could ever be a vegan though. They just eat straight plants.
Yeah, I tried that for like.
It's like plants, nuts, and rice and beans.
It was like you were vegan for January. Did it last year?
Like eat anything that contains meat in it at all.
And you can't eat that like dairy in it too. Like,
No dairy, no eggs, no cheese.
food you can't
Anything
have.
that comes from an animal that you eat.
Right. David's like, no. I have to have cheese. Like, I can't live without cheese.
And I really like sushi.
And I love sushi. Sushi the best. Alright, Bree, did you get it? Okay. Alright, so this side is like what you did yesterday, kind of. This side was meant to be easier. Okay? So if we already have y equals a number, right? So I can just plug that 2 straight into here. So you already have your y, and now you need to find your x. So this is even easier. You don't even have to do the other problem. So -3x minus 5y, but what's y? 2. -3x minus 10 equals 8. Add 10 to both sides. Divide by -3, x is -6. Okay, so those are supposed to be easier because I already gave you y equals. So if we look at 14, let's look at 13. We already have y equals. We already have a variable solved for. Okay, so you can just plug this straight into y. So 2x minus 2y, but what is y in this case? For number 13, what's y? -6x plus 5. Right. So I took this whole thing and plugged it into y. Okay, so I have 2x. What? Oh, thank you. Alright, so 2x plus 12x minus 10. So I have 14x. I'm going to add the 10 to the other side. Divide by 14, x is 1. Alright, am I finished? No, I need to find the y value. So I'm going to plug, I just solved for x, I'm going to plug it in. Negative 6 times 1 is negative 6. Negative 6,
Wait, didn't you positives?
it was a negative 6 up here.
Oh.
Negative 6 times 1 is negative 6. Negative 6 plus 5 is negative 1. So my coordinate is 1, negative 1, and that is one solution. So this side's meant to be easier because you didn't have to solve for a variable at all. Okay? Or you had to solve for one variable, but one's already solved for you. So that's only half the work on this page. Can I flip to the next one? So some of these are more like what we just did. So here I would add 2x to both sides. Y equals negative 7. Hold on, guys, 1 second. All right. So then I solved for this y. So I have negative x minus 3y equals negative 14. But I just solved for y as this. So I'm going to plug it in here. So negative x, distribute that 3. All right, and then that is negative 7x. Subtract 21 from both sides. That's negative 35. Divide by negative 7. X equals 5. All right. Brandon. Or Brendan. This negative 7x, I did negative x and negative 6x. Okay, and then what do I need to do to finish this problem? Plug it in. Perfect. So I'm going to plug it into here. So negative 7 plus 2x. What did we say? 5. Oops. So 2 times 5 is 10. 7 plus 10 is 17. So I have one solution, and it's 517. All right, so you have 43 minutes to finish this. Yeah, it should be, what, that's 5, that's 9 problems. So you have 9 problems to do, and then once you're done with that, show me so I can check your answers. And then you've got the second section on Delta Math for homework. You have 40 minutes. 40 minutes. Okay? Okay. I don't think any of them are decimals. Which one are you working on? 12. 4x minus 5y equals 3. That's positive 35. Subtract 35, I get negative 32. Is that where you messed up?
I know where I messed up.
Okay. I started 12 for you, so that's 8.5 problems. It's really 8.2 problems. All right. So just to kind of recap, the other day we solved for solve by using graphing, and today we solve by substitution. Substitute means to replace the variable with the equation that you found. Okay? So I started number 12 for you as well, so that's only 8, like almost 8 problems.
And excellence goes first, really, thanks.
Make sure you write one solution, no solution, or infinitely many. So I did number 12, so really you have 8 problems now. So you have 40 minutes to do 8 problems in the second section of Delta Math, which I think only has 5. Okay, so come up and check your work. Should you check yourself before you wreck yourself? If you want to listen to music, go ahead. I love